Okay, so I had another request for this problem, and let's figure this out here. So this is a mechanism problem, and remember this is chapter 16 or number 16 for me. It might not be that for you, but let's see here. We have what is the rate law for the following mechanism for the overall constant k? Okay, so all you do here have A, B going to C, B, C going to D. Okay. New. Okay, I have A plus B goes to C, and then I don't remember the rest. B, C, D. B plus C, D. This was fast, this was slow, and I believe this was in equilibrium. Let's make sure. Yes. Okay, so the first thing you need to do is write your rate law for the slow step. Okay, so write the rate law for the slow step using the reactants. So for the slow step, my rate equals to K, and I just use these reactants right here. Since it's a mechanism, I could do a direct rate law. So that would be B times C. Now, if this was like a 2C, let's say, then that would have been C squared. Okay, but it's not. It's just to the 1. Okay, now we need to see, is there an intermediate listed in here? Well, let's see if anything cancels out. Okay, there's not an A anywhere. Or at least there's only an A right here. There's a B, but there's not a B on the product side. But you see here that there's a C listed on the product side and a C listed on the reactant side. Since they're on opposite sides of the equation, they will cancel out. So C equals my intermediate. Well, in your rate law, you're not allowed to have an intermediate in here. So C cannot be in here. You have to get rid of it. How do you do that? You go to the fast step. Okay, so we're going to write the rate law for the forward and reverse reaction. Okay, so for the fast step, so this was for the slow. This is for the fast. This is where you figure out what to plug in. So for the forward reaction, rate equals to A times B. So the forward, so we're looking at A and B. So A runs in, A and B are our reactants. Okay, now for the reverse, rate equals to, and you see there's only C listed here, so it'd be C. Now you see they're in equilibrium with each other. It's almost like an equal sign. Well, that means the rates are equal. Rates are equal. So R equals to R. So I can actually set these equal to each other. I can say that A times B equals to C. And again, that is just because the rates are equal to each other. Since A times B equals to R and C equals to R, I can say A times B equals to C. Anyway, so they'll always be set equal to each other. Now do you see that I have an answer for C? So instead of putting C in there, I can put A times B. And so I'm plugging this back into there. Okay? So another way of writing this is R equals to K times B, which is the first part of this. But now instead of writing C, I'm plugging this into there, which is AB. A, B. Okay, now I'm going to simplify this a little bit. Since I have two B's, I'm going to put rate equals to K, and then B squared times A. That is my final rate law there. Alright, so that's the first part of it. That's A. Now let's look at B. Okay, it says consider this reaction. 2x 2y2 plus z2 yields 2x2y2z. And the rate for this is x2y2z2. Okay, so that means this is a slow step here. So we want to see what's a possible mechanism. Okay, so let's look at the first one. So you get the rate law from the slow step, and let's see, and if the slow step is first, if it's listed first, then you don't have to do any substitution. You know, like we did over here when we worked out A, where we had to, substitute what C actually equals to. But do you see that the fast step is listed first? That's a big hint that you're going to have to plug things in. Okay, it's not going to be exactly straightforward. But since the slow step is listed first in some of these, you don't have to do that. It's just whatever the slow step is. So for here, the slow step, the reactant is just Z2. Okay, so if we wrote for A, if we wrote the rate law for A, that would just be rate equals to K Z2, because that's what's in the slow step. And it's listed first, so that's all we have to write. We don't have to plug anything in. Okay, so for B, it would be X2 Z2. Okay, so for B, R equals to K X, where is it? X2, Y2, Z2. C, the slow step is also first, and we get X2, Y2, Z2 again. Okay, so we'll have to look at both of those. If R equals to K, X2, Y2 times Z2. And then finally, let's look at D. This would be the fast step here. So Z2, X2. So you had to plug this in so you get basically Z2 times X2, Y2 squared. So with D, if you did it correct, Z2, X2, Y2 squared. And then E, let's see, we would get, and then, sorry, D, you would have to plug it in. So you see X4, so you'd write the slow step. So it starts off as X4, Y4, Z2 times Z2. X4, Y4 can cancel out, so you have to set it equal to each other. So what you'll end up getting is X4, Y4 equals to X2, Y2 squared. Anyway, so if you do it the same way you did A, this is what you should get. And then here, E equals the same thing. You should get R equals to K, X squared, Y squared, or X, Y, and then Z2. Okay, well, right now, right away, we know that we can cancel out 3 of these because it says the rate law needs to be X2, Y2, Z2. So the rate law is set in the problem should be K equals to X2, Y2, Z2. Okay, so let's see which ones don't equal to this. Well, A doesn't equal to that. D does not equal to that. And E does not equal to that. Okay, so let's look at B and C more closely. So basically all I did with these is I figure out the rate law for each and every one of those. And then you see how it says here, which has a rate law of this. Okay, now for this reaction here, so now I had to match up, and they have to at least have a rate law of that once you figure out the rate law for each of these. Okay, so again, figure out the rate law for each of these and then compare it to this. If you have a slow step first, you just have to write the rate law for the slow step. If you have a fast step first, that's when you have to plug things in. Okay, so let's look at B and C here. Alright, so we know we need to look at B and C. So if we look at C first, or we can look at B, it doesn't matter. Well, let's look at when we cancel everything out, will it equal to this overall reaction that we're trying to get? Okay, so let's do that. So is there an X2, Y2 on the product side? I don't see one. Here's an X2, Y2 on the reactant side. So when you add this together, X2, Y2, you should get 2X2, Y2. Here, let me maybe help if I rewrite these here. So x2, y2, let me minimize both of these. Nope, that's not what I wanted. So that we can see both of them at the same time. So I can rewrite these. Okay. I don't know where I was writing it. There it was. I'll just rewrite it. Okay, right here. Okay, so for b, I have an x squared y, or not squared, y2, z2 goes to x2, y2, z, plus z. And then over here, x2, y2 plus z yields to x2, y2, z. So let's cancel everything out here. Let me change this. Let's cancel this out. So x2, y2, y2. See, these two are the same here. So when I add them together, I'm going to get 2x2, y2. Now let's look at here. Can z2, is it by itself anywhere? No, so I'm going to have a plus z2 yields to, okay, so here's a z and here's a z, so z on my product, z on my reactant, so that cancels out. Then over here, x2, y2, z, that's the same as the one right below it, so I'm going to have two of those, so 2x2, y2, z. Now do you see here, 2x2, y2, and then over here, z2 yields to 2x2, y2, z. So when I add this reaction together, I get exactly the reaction I need. So the answer is B. But let's look at Z really quick just so you can see why. It's not Z. I mean C, not Z. Okay, so if I write C out, it has x2, y2 plus z2 yields to x2, y2, z2. And then over here, x2, y2, z2 yields to x2, y2, z plus z. Okay, so let's see here. Is there a, let me write this better, plus a z. Okay, there's not a z anywhere else, like by itself, so z would stay. So I'm going to have a z plus, you see x2, y2, z, and this is a x2, y2, z2. So these are different, okay? And over here I have an x2, y2, z2. So x2, y2, z2 on the reactant side and an x2, y2, z2 on the product side. All right, so that will cancel out. So this cancels because it's the same as this one right here. Okay, now let's look here. Do I have another x2, y2, z on the reactant side? I do not. See, this is a z2, not just a z, so that doesn't cancel out from over there. Okay, so my products will have an x2, y2, z. Now over here, there's not a z2 anywhere. There's a z, but not a z2. So z2 carries down, and then x2, y2. And if you compare it to the equation from over here, do you see it doesn't match up? So C could not be it. So again, do you see here that like x2, y2 is different than x2, y2, z, because this one has a z in it, and this one does not. Anyway, so you cancel everything out, see that's left. All right, and once you do that, you see that this, B, is the only one that matches everything.